Hello everyone, my name is Shreya Bhatt and I am a student at MIT Academy of Engineering. Welcome to my presentation on DevOps tools and automation strategies. In this session, we will explore various tools that enable automation in software development and deployment processes, helping organizations deliver software faster and with greater efficiency. Understanding DevOps principles, practices, and benefits. DevOps is a combination of cultural practices, tools, and philosophies aimed at improving collaboration between development and operations teams. The goal is to deliver applications and services at high velocity. In traditional workflows, development and operations worked in silos, often causing delays. DevOps eliminates these barriers by fostering a collaborative environment. DevOps incorporates practices like continuous integration, continuous delivery, infrastructure as code, and automation monitoring. These ensure a streamlined workflow. Automated testing is a key DevOps practice, ensuring that code changes do not introduce bugs. Adopting DevOps practices leads to faster delivery cycles, improved software quality, increased efficiency, and enhanced collaboration among teams. Companies like Amazon and Netflix use DevOps to roll out updates quickly and handle high user traffic efficiently. GitHub, mastering the collaboration ecosystem. GitHub is a platform that provides version control and collaborative tools for software development. It is built on Git, a distributed version control system. Key features include code hosting, pull requests to code reviews, and GitHub Actions for automating workflows. A developer can create a feature branch on GitHub, make changes, and submit it for review. Once approved, it can be merged into the main branch without conflicts. Version control with Git. Git allows you to track every change made to your code. This makes it easy to revert to previous versions or understand what changes were introduced at specific points. If a new feature causes errors, Git can help revert the project to the last working version. Multiple developers can work on their own branches and merge their changes into a shared repository without conflicts. If one developer works on the login feature and another on the payment gateway, both can work independently without affecting each other's code. Code management. Git acts as a single source of truth for your team, ensuring everyone works on the latest version of the project. Git's centralized repository ensures that no developer is working with outdated code. Continuous integration and continuous deployment CI/CD on GitHub. Continuous integration ensures that new code changes are automatically merged and tested in a shared repository. A CI pipeline might test a new login feature against existing functionality to ensure it doesn't introduce bugs. In continuous delivery, tested code is automatically deployed to staging or production environments, making updates ready for release. This allows teams to release updates quickly when needed, such as fixing a critical bug. Continuous deployment goes a step further, automating the entire release process so every approved code change is immediately available to users. E-commerce platforms like Flipkart use this to roll out frequent updates during sales events. Jenkins. Jenkins is an open source automation server used to implement CI/CD pipelines. It automates repetitive tasks like testing and deployment. Using Jenkins, you can automate nightly builds and test cases, saving hours of manual effort. Jenkins offers an extensive plugin ecosystem, enabling integration with tools like Docker, Kubernetes, and GitHub. For example, plugin can trigger a build on Jenkins whenever there's a new commit on GitHub. Jenkins can scale across large projects using master agent architecture where the master coordinates tasks and agents execute them. Multiple agents can run tests simultaneously on different platforms, speeding up the process. Jenkins architecture and components. Master node. The master node is the brain of Jenkins. It schedules jobs, manages builds, and stores configuration details. The master node ensures that a failed test in one job doesn't halt other running jobs. Agent nodes. Agent nodes execute build jobs assigned by the master. They can run on different machines, optimizing resource usage. A Windows agent can handle .NET builds while a Linux agent can handle Python tests. Plugins. Plugins extend Jenkins functionality, enabling integration with tools like GitHub, Maven, Selenium, Docker, Kubernetes. For a web application, the Git plugin fetches code, the Docker plugin builds a container, and the Kubernetes plugin deploys it. Jobs. Jobs are tasks Jenkins automates such as building, testing, and deploying applications. They can be linked in pipelines for complex workflows. A job might clone code from GitHub, run unit tests to build the application, and display it to a server. Terraform Infrastructure as Code. Terraform is an infrastructure as code IAC tool that provisions and manages cloud resources using code. A Terraform file can create virtual machines, storage, and network automatically on AWS. The workflow involves writing configurations, initializing the project, planning changes, and applying them. Example, using the Terraform apply command, you can deploy resources exactly as defined in your configuration file. Terraform configuration and syntax. Terraform uses HashiCorp configuration language HCL to define resources. It's simple, readable, and ensures consistency. Here's an example to launch an EC2 instance on AWS. Resource management. Terraform tracks resources states in a state file, ensuring accurate updates and avoiding unnecessary changes. If you add a new server in your configuration, Terraform only deploys that server without affecting its existing resources. Terraform modules and reliability Terraform modules and reusability. Modules allow you to break down infrastructure into reusable components, making configurations more organized and scalable. A module for a database cluster can be reused in multiple projects without rewriting the configuration. You can share and version modules promoting collaboration across teams. Company can maintain a standard networking module for all projects ensuring uniformity. Terraform state management and teamwork. Terraform tracks the actual state of your infrastructure in a state file. This ensures consistency between your configuration and the deployed resources. If you create an EC2 instance, the state file contains details about its ID, IP address, and other properties. The state file ensures Terraform applies only necessary changes, avoiding unintentional modifications. If you add a new S3 bucket in your configuration, Terraform creates only the bucket, leaving existing resources untouched. Remote backend. For teams, Terraform supports storing the state file remotely using backends like S3 or Terraform Cloud. This facilitates collaboration and ensures disaster recovery. A remote state file enables multiple team members to work on the same infrastructure safely. Terraform providers and cloud integration. Terraform AWS provider lets you manage resources like EC2 instances, S3 buckets, and RDS databases. Using Terraform, you can create an auto-scaling group for EC2 instances based on traffic. The Azure provider supports resources like virtual machines, storage accounts, and networking components. A Terraform configuration can deploy a full Azure virtual network with subnets and gateways. The Google Cloud provider manages resources like compute engine, instances, cloud storage buckets, and Kubernetes clusters. You can use Terraform to deploy a Kubernetes cluster on Google Cloud with all required resources. Terraform best practices and advanced concepts. Breaking configuration into reusable modules improves maintainability and scalability. Instead of duplicating code for setting up virtual machines, use a module that handles all the configurations. Store Terraform configurations in version control systems like Git to track changes and collaborate effectively. If a change breaks the infrastructure, you can revert to a previous working version using it. Test your Terraform configuration to ensure they produce the expected results before applying changes. Use tools like TerraTest to automate the testing of your infrastructure. Kubernetes, the DevOps game changer. Kubernetes is an open source container orchestration platform that automates the development and deployment, scaling, and management of containerized applications. If your app receives high traffic, Kubernetes can automatically add more containers to handle the load. Kubernetes aligns with DevOps principles by automating repetitive tasks, enabling faster releases, and fostering collaboration. Developers focus on building features while Kubernetes handles deployment and scaling. Kubernetes architecture, nodes, pods, and services. Nodes are physical or virtual machines that run Kubernetes workloads. In a Kubernetes cluster, worker nodes host applications, while the master node manages the cluster. Pods are the smallest unit in Kubernetes, containing one or more containers that share resources like storage and networking. A web app and its database container can run in the same pod for seamless communication. Services expose pods to external users or other pods, ensuring stable communication even if pods are replaced. A load balancer service can distribute user traffic evenly across multiple pods. Kubernetes networking and service discovery. Kubernetes automatically discovers services within the cluster, enabling seamless communication between components. A web frontend can dynamically discover and connect to backend service as pods scale. Network policies define rules for pod communication, enhancing security. Example, you can restrict certain pods from accessing sensitive data services. Ingress provides a single entry point to expose services to the internet and route traffic based on URL paths. Traffic to /API can be routed to the backend service while /UI goes to the frontend. Monitoring and logging in a Kubernetes environment. Kubernetes integrates with tools like Prometheus to collect metrics from pods, nodes, and services. Prometheus tracks CPU and memory usage, altering teams when resources are low. Tools, tools like Fluentd and ELK Stack aggregate logs from Kubernetes components for analysis. If a pod crashes, logs can help identify the root cause. Kubernetes and continuous integration, continuous deployment. The CI/CD process begins when developers push code changes to a version control system like GitHub. This triggers the pipeline. For instance, when a developer submits a new feature for a web application, the pipeline detects the change and initiates the build process. Automated build and testing ensures the code is compiled and checked for errors. If tests pass, the pipeline moves forward. A build step compiles the source code into an executable file, while tests ensure on no functionality breaks, such as login tests for an e-commerce site. After passing all tests, the application is packaged into containers and deployed to a Kubernetes cluster for staging or production. Container image containing the app is pushed to a registry like Docker Hub, and Kubernetes deploys it as a pod. Scaling and high availability with Kubernetes. Kubernetes supports horizontal scaling, automatically adding or removing pods based on workload demands. If user traffic spikes during a flash sale, Kubernetes adds more pods to handle the load. Load balancing distributes traffic evenly across pods, ensuring optimal performance and reliability. A load balancer prevents downtime by rerouting traffic from overloaded pods to others. Kubernetes replicates pods across multiple nodes, ensuring services remain available even if a node fails. If one node hosting a backend service crashes, Kubernetes routes requests to pods running on healthy nodes. The future of DevOps with Kubernetes. Serverless Kubernetes simplifies resources management by automating infrastructure provisioning. With serverless platforms like Knative, developers focus solely on writing code, leaving Kubernetes to handle scaling and deployment. Kubernetes extends to edge devices, enabling efficient application deployment closer to users. IoT devices in a smart home can run Kubernetes for managing local applications. AI and machine learning are enhancing Kubernetes by optimizing resource allocation and automating complex deployments. AI driven tools can predict traffic spikes and rescale resources to avoid downtime. Thank you for watching this presentation on DevOps tools and automation strategies. I hope you found this session insightful and useful for understanding how these tools work together to enhance software development. Stay tuned for the next part of our video. If you enjoyed this video, please like, share, comment, and subscribe to my channel for more content like this. Don't forget to ring the bell icon to stay updated with our latest videos. Thank you.